If you're moving into creating visual effects with a general background in video editing, you'll probably find a timeline-based compositor like After Effects or Apple Motion to be a natural extension of the skills you already know. But if you've ever looked at behind-the-scenes video of high-end visual effects artists at work, you may have noticed that they work with a very different set of tools: nodes. Nodes are a completely different way of approaching visual effects work. Where applications like After Effects are centered around the timing of things, node-based compositing is much more concerned with the spatial relationship between them. The good news is that in the next few minutes, we'll help you wrap your head around the whole concept of nodes and how to assemble a basic composite. And once you have the essentials under your belt, you'll be able to quickly pick up the specifics of individual tools and effects. We'll be working here with Blackmagic Fusion because it's a powerful, modern node-based compositor and because, well, it's free, which is a pretty good price no matter how you dice it. Watch the Fusion Quick Start video to become familiar with its basic operation. But the principles you learn here will translate easily to any professional node-based compositing system. Let's take a look at one more effect to help solidify your understanding of node-based visual effects work. Suppose we want to create a glow around the blue lights of the UFO. What we need is to isolate just the blue lighting and build the glow from that. Now, we could go back to our 3D app and just render out the lights by themselves, but we already have what we need right inside our compositor. We begin by clicking in the gray space of the node flow area. This deselects any selected nodes. By default, Fusion will automatically connect new nodes to any node that's selected, and in this case, we don't want that. Now we'll search for and add a Luma key node. We'll connect the Luma keyer to the output of the UFO node and then load it into the viewer. You can see that right out of the box, the Luma keyer has gone to work isolating the brighter parts of the image. Going back to our analogy of streams of water, you'll now see that we have two streams flowing out of the UFO node. Essentially, what we've done is divert an identical copy of the UFO stream into the Luma keyer. Each copy of the stream is identical. In fact, we could have dozens of streams all flowing from the same node, each carrying an identical copy of the node from which they're flowing. In this specific case, the Luma keyer is already doing a great job of isolating the highlights. We'll just tighten up the contrast to make those highlights more solid. Then, to create our glow, we'll use the compositor's best friend, the blur node. Making sure the Luma keyer node's still selected, we'll add the blur, load it into the viewer, and then adjust the size to create a nice strong glow effect. The last step is to composite our glow over the original image. We'll select the merge that currently represents the final state of our shot and add yet another merge beneath it. Connect the input of the new merge to our blur, and we're done. Well, almost. If we load the new merge into the viewer, we'll see that the new element dulls and flattens the shot. That's because instead of simply compositing the glow over the shot using the normal blending mode, we really instead want to screen it over. And with that, we're done. No need to buy a custom plugin, just a couple of extra nodes, and our effect is achieved. Let's quickly recap. What we have here are two versions of the UFO. One is being composited over the background in the usual fashion, the other is being keyed, then blurred, and then screened over the rest of the composite. Notice that the main version of the UFO is unaffected by the Luma keyer or the blur. Why? Because we have another copy of the UFO stream diverted before it passes through the Luma keyer and blur filtration plants, so its water arrives at merge 3 untainted. If instead we chose to take a copy of the stream after it had passed through the Luma keyer and the blur, we get an entirely different result. And that's the true power of node-based compositing. No matter how radically you alter the look and feel of an element in your comp, you can always grab a fresh copy of the image upstream before all the other nodes have done their dirty work. Which is what makes node-based compositing a truly non-destructive, non-linear way to work. But what about the benefits? What did we gain by creating our composition with nodes instead of a timeline? If the goal was just to stack together elements, then we really haven't gained a whole lot. But when we want to start adding effects to elements, well, that's another story entirely. To sell this shot, we'd expect to see the UFO casting a shadow on the farmyard. To simulate this, we'll add a color correction by selecting ground and adding a color corrector node. Dragging the gain slider to the left, we're effectively plunging the entire farmyard into shadow. Think of the color corrector as a water filtration plant. As the stream of water passes through the color corrector plant, it gets filtered by the node. In this case, the stream's water is being darkened by the color corrector as it passes through. Notice that the sky and the Eiffel Tower are unaffected. Why? Because their streams aren't passing through the color corrector node. Only image data that's upstream from the color corrector node will be color corrected. If we were instead to add a color corrector to the node tree after the ground stream had merged with the Eiffel Tower and the sky, all three elements would be affected. Why? Because their combined stream is passing through the filtration plant, darkening the water. Let's delete that unwanted color corrector and get back to the task at hand. So we have created a shadow, but it darkens the entire farmland. That would work if we were simulating an eclipse, but we only want to shadow the areas of the scene where the UFO would be blocking the skylight. What we need is a matte to mask off which parts of the image will be color corrected. Let's take a look at the shadow matte node we have over to the right. If you look carefully as we play back the timeline, you'll see the light areas of the matte move from screen left to screen right as the UFO crosses over the farmyard. If we connect the shadow matte to the effect mask input of our color corrector, only those light areas of the matte will be color corrected. In other words, the darkening effect of the color correction has been masked off by the shadow matte. We can now adjust the strength of the shadow by easing off the gain adjustment. Playing back, the UFO seems much more integrated with the rest of the shot thanks to the shadow. This kind of masking can certainly be done using layer masking in an application like After Effects, but in a node-based environment, you have much greater flexibility and visual feedback. Another nice feature of node-based compositing is the ability to instantly see your comp at any state. Simply by flicking a node toward one of the viewers, we can see how the composite is looking at that point in the tree. So here, we see what the farmyard looks like before applying the shadow correction, and this is what it looks like afterwards. This is great for troubleshooting your shots, and it's often useful to use the second viewer to analyze the individual elements while keeping the first viewer set to the node that represents the final state of the composite. Clips. We've enabled the tile pictures on these nodes for illustration purposes. Clicking on their view indicators, we can see we have footage of a farmyard, a CG rendering of the Eiffel Tower, an ominous UFO mothership, a background sky, and a matte showing where the shadow of the UFO should fall on the farmyard plate. Let's put them all together. We'll start by selecting the sky element, which is the layer we want at the bottom of our composition, and then add a merge node. We'll step quickly through building our node tree here, since these steps are all performed in the Fusion Quick Start video. If you haven't watched it yet, now would be a good time. Now we'll add the Eiffel Tower to the foreground input of the merge node. Flicking the node into the viewer, we can see the Eiffel Tower hovering happily in space. Now let's composite our farm over the top of that. We'll add a new merge to the current one, attach the ground node to its foreground input, and then flick the merge into the viewer to see the result. One more merge to connect the UFO, then flick it to the viewer and press play to cache and preview the timeline. So we've created the composition, but you're still none the wiser as to what's going on, right? And those of you who've been compositing in layers for years will no doubt argue that you could have added a dozen or so layers to your timeline in the time it took us just to assemble these 4 elements. And you'd be right. But don't panic. You're moments away from understanding node-based compositing and the reason it's worth this little extra setup. Okay, imagine that each of the image nodes, UFO, ground, tower, and sky, is a stream of water starting high up in the mountains. These streams of water flow downhill, thanks to gravity. Now, the tower and sky clips flow downhill and run into a merge node. In this case, it happens to be called Merge 1. Just like real streams, when they merge together, they create a new single stream or river. That new stream is a combination of the 2 original streams. So we have a single stream flowing out of Merge 1. Along comes the ground clip. The ground clip and the stream flowing out of merge 1 now flow into merge 2. What's the result? You guessed it, a new single stream flowing out of merge 2 that's a combination of the ground clip stream and the merge 1 stream. This happens one more time to combine the UFO stream at merge 3. In a larger composite, this could happen dozens of times before we get to the bottom of the hill. And that's it. At the very bottom of our hill is a single stream coming out of merge 3 in this case that's a combination of all the streams that have flowed together further up the hill. And it's this single stream, the combination of all our images, that can now be rendered out to disk as our final composite. Simple enough, right? Okay, then let's review. Node-based compositing focuses on spatial relationships rather than temporal ones. A helpful analogy is to think of node-based compositing as streams of water flowing downhill, being affected and filtered by any nodes they pass through on the way. The mask input of a node can be used to limit the effects of a node to a specific portion of the image. You can view the state of a composite at any point in the node tree by simply loading the node into one of the viewers. And a powerful feature of node-based compositing is the ability to branch 2 or more streams off the same node output and affect each stream with a completely different set of filters and color corrections.